Construction is a very interesting industry because what we've had historically is a declining productivity curve for the past 50 or so years.
The demolition and construction industry is developing at a faster pace than ever before. New equipment, new technology and new forms of fuel are revolutionising the sector and changing the very landscape of the industry. We have created an entirely new audio and video podcast series to chart that progress and to help keep you abreast of these rapid and revolutionary changes. This is Tech Foresights.
Built Robotics started in 2016, and our founder, Noah Reedy Campbell, was actually, as a kid, he grew up working in construction. His father was a carpenter and contractor, and he was familiar with the industry and how things were done as a kid. He understood how difficult of an industry it is. And I think, when he was thinking about what he wanted to do next, he thought, what if we could take all the advancements we've made in artificial intelligence, machine learning, robotics that other industries have had and apply it to construction where it's really needed?
I guess that kind of leads into my next question. Why is construction so well suited to the built robotics style of technology?
Construction is a very interesting industry because what we've had historically is a declining productivity curve for the past 50 or so years, whereas other industries have actually increased productivity through technology. And construction has been one of the few that have not really embraced or taken advantage of what technology offers. And so we're facing sort of historic problems in construction around labor, around productivity, around costs, around speed, around safety. And so these are all things that technology like robotics can really help address. And that's why things like automation, machine learning, artificial intelligence, robotics are really poised to help construction become an efficient, productive sector once again.
That decline in productivity it comes as quite a surprise. Is that down to sort of a conservatism within the industry, just a failure to grasp what technology can bring to the party?
Yeah, I think what we've seen is the general consensus is that construction is against change. They don't quite get technology. But that's actually incorrect. I think construction, if anything, they're usually some of the first to use the most powerful kinds of tools. They're always eager to improve efficiency. They're always obsessed with safety. But the reality is that construction workers also have to lean on what works, and they need to meet deadlines and need to rely on what is effective. So you have two opposing forces. On one hand, they recognize the importance of the best tools for their talented workers. On the other hand, they also need to lean on what they know and what will achieve predictable results. So it's hard for them. They're kind of stuck in an interesting place where it's hard for them to experiment and work with technologies, which is why it's important when you're developing advanced technologies to make sure that they're easy to adopt, they work in existing workflows, and they're kind of low capital investment, so it's easy to test and deploy.
We've mentioned these systems. Let's get into the nitty-gritty. How does the system actually work? Take me through what Built Robotics can actually bring to the party.
Built Robotics, we've taken a little different approach. Our biggest benefit is that we're an aftermarket upgrade for heavy equipment, and that means what you already own or what you're already renting, you can automate or upgrade to a robotic solution. And we do this through a hardware product that we install on the tail of excavators. By the way, right now we're focused on excavators, although we have automated other kinds of heavy equipment in the past. So you can take an excavator, you put our exosystem, we call it, on the back of the machine, on the tail. And once that's installed, we add a few sensors on the machine, including cameras, IMUs, GPS. And that actually integrates directly into the hydraulic system and the CAN bus of the piece of equipment. And once that's set up, our software can run and control the machine fully natively as if it were a totally integrated solution.
Now, one of the things, and I have to say, this is something I hadn't come across before. While I was at Balmer, I spoke to a Chinese manufacturer, and apparently in China, it's perfectly acceptable to have a machine unmanned in operation on a construction site. Apparently in Europe, we don't have that. What is the situation in the States? Can you, because I know you're further ahead with things like driverless cars and that kind of thing with Tesla and what have you. What is the situation in the States with that?
It does vary a lot. Even within Europe, there's different kinds of regulations and there's special kinds of zones where autonomy is more acceptable. In the US, typically speaking, On private roads, private projects, private land, autonomy can be used pretty freely in construction. Agriculture has different regulations. Some of these are historic leftovers from different issues that still are on the books as rules. But typically, when it comes to autonomy in the US, you're free to implement it on your private job sites, private projects. When we talk about autonomy on public roads, like Tesla, for example, that's a whole different set of regulations. But our machinery as heavy equipment operates on private projects.
When I've been speaking about autonomy and robotics in the past in relation to construction and mining, there seems to be levels to it. Is yours an entirely autonomous system, or do you have operators tucked away in a station keeping an eye on things, or is it a combination of the two?
Yeah, so when the robot is operating, it is a fully autonomous operation. You start the robot and it can dig its task. This is somewhere in between SAE's 5 level of autonomy. This is somewhere in between 4 and 5. 5 is sort of fully autonomous system that requires 0 human input. Ours is fully autonomous when it's working on a task, but it still requires a human to start the robot and maintain the machine.
In terms of actually planning that task, specifically with an excavator, when you're talking about digging, I take it you're drawing that from things like GPS and the systems on offer from the likes of Trimble and Leica, perhaps. Is that the case?
Yes. So when you're defining a task, it's pretty straightforward. You will shoot GPS points and collect elevation data through the GPS, and then you'll also define your geofence with GPS points. Once you do all that, you could upload those files into our software system, which we call abreast, and then you could start your task. You could define basic things around the trench with depth, spoil location, egress ramps, the kind of entry motion, how it cleans the edges. So there's a lot of number of features you could do for trench automation. And then once you have that all set up, you press the start button, the robot does the rest.
One of the things that we saw at Balmer was the fact that, specifically when you, again, I mentioned Bobcat, they were directly opposite you, so I'm sure you saw some of the things they were up to. They've got, for example, this TX7 machine of theirs, the compact loader, all electric, so there are no hydraulics on there. I take it your system can accommodate that kind of thing as well?
It can. We haven't launched any kind of on-time solution on a fully electric machine, but it's actually very exciting for us because electric actuators work much more precisely than hydraulics. There's a lot less variability in how where the movement of the arm will be, for example. So I think with electronics and electronic actuators and electronic equipment and autonomy together, you'll get a very kind of precise machinery.
You mentioned the fact that your system fits onto an existing excavator. I assume it can also be demounted as well, so you could have maybe the machine in operation by human interaction on one hand and then into automation afterwards?
Yes, that's one benefit of the aftermarket upgrade. You can run your machinery fully manually if you'd like to. You could turn off the exosystem, jump in the cab, run the machine manually, and then when you're done, you could jump back out and start it in autonomous mode. And this flexibility allows you to really use your equipment how you want to use it and use it for the right kind of application for the right kind of task.
That's been one of the interesting things that we've discussed on our show before, is this notion of potentially having people working. I'm thinking here about remote control, but this idea of having people maybe working a shift in the US and then handing off to a team in Australia, then handing off to a team in Europe somewhere. So you've got a 24-hour operation. I guess with yours, it's literally a case of here's an 8 or 10-hour operation, switch to automated mode and let the machine carry on.
That's right. You don't need a human to be watching the machine, or there's no remote control of the machine. So you can, as long as the machine is fueled, you can start it on its task and it'll work as long as you need it to. And we've done extended operations before. We've done nighttime operations, and then that way, when the crews come in the morning, they'll have ready trench to work with. One
of the things that really surprised me at Balmer was the fact that, speaking to a couple of companies, the one that really sticks in my head was Bobcat, where they were talking about remote control and autonomous machines, is the notion that equipment manufacturers are now having to kind of wrap their heads around the notion of ethics. We are talking about equipment here or a system here that could potentially render one or more people unemployed. It's a strange notion to be dealing with, isn't it? Because obviously, we're looking for productivity, machines like your system don't go sick, they don't have maternity or paternity leave, they don't go down with COVID, but they could ultimately replace a human being, couldn't they?
What we see is that what we're trying to do is we're automating tasks and not jobs. And why that's true is that construction is facing difficult labor problems. And with autonomy, you can help do the mundane tasks and free up your labor to work on more meaningful work. And if you can take on more work and build faster and cheaper, you could actually grow your business. And we think it'll grow the industry to have automation, which will make it easier to hire more and more people. And as we do that, the kinds of jobs may shift a little, but Built Robotics, for example, is very proactive in upskilling and uptraining people who work with autonomy. We have a multi-year partnership with the union in the US, the IUOE, and we see that as a way to help train existing operators on robotic tools, because robots still need people to be involved with them. It'll just be different kinds of tasks and different kinds of jobs.
Are there any specific tasks to which your system is most suited? I mean, you just mentioned mundane tasks, because I don't consider excavating a mundane task, but is it best at repetitive work? Because I have a foot in both camps of both construction and demolition, and demolition is, I could really see the benefits of autonomy there, because obviously it's a very potentially hazardous area, but it's a constantly changing building that you're working upon. Could your system be taught to deal with that kind of thing?
Yeah, over time you can. We sort of see it as dull, dirty, dangerous work is most suited for autonomy. And trenching is a good example of work that can take miles and miles of trench to be dug, and it could be fairly repetitive, so it's a good use case for autonomy. And demolition is also a good one because it's dangerous work, and it's good to have less humans actually in the site where they could be hurt. Demolition can be a little bit more complex, of course, because the building is changing shape, but trenching is similar in that you're manipulating the ground and you're changing what the terrain is like. And when we approach autonomy, we look at both what our customers want and what's feasible with the technology, and we kind of have a conversation and figure out what should be automated. It starts off slow, and you build on each kind of application.
I assume you've actually got this system out at work in the US. What is the customer feedback like? What sort of feedback are you seeing from the workplace?
Yeah, a lot of excitement, I'd say. I mean, there's skepticism at first. I think construction is a very hands-on industry, and they like to see things that are working in front of their eyes. So once they see the robot kind of doing its job, just like any other person on the job site, they're quite pleased with it. And I think a lot of veterans actually, people who are younger in construction kind of get the value proposition, but people who have been working in construction for a long time appreciate it even more because they're familiar with all the technology, all the difficulties of the job, and they see the value of autonomy to help make their job safer, make them easier, and help them focus on things they enjoy in their work. One
of the issues that we seem to encounter with things like GPS and real-time data going back to a central location, that kind of thing, is an issue of connectivity. How do you get around that, or is that machine just a complete standalone and doesn't need to be connected to anywhere else?
The way our robots work, they do require GPS connection to get localization information and positioning. But in terms of network connectivity, they do all the processing locally. So that box we put on the back, the exosystem, contains the computer and all the software needed to run the robot. Now, if it's not connected to the internet, it can't send data to the back office. You can't view real-time statistics remotely, but everything the robot needs is local. That way it can operate in fairly remote conditions. You
mentioned at the start this idea of declining productivity within the field of construction. How does the built robotics system stack up against an experienced operator?
Yeah, the robot works pretty efficiently compared to your average operator. They're sort of one and the same. When it comes to a super experienced operator, I mean, the robot isn't quite as good as someone who's really knows their technique. But the benefit is that over time, a human will become fatigued and they'll need rest and breaks. A robot can sort of maintain a consistent level of performance. And that's the real benefit, is that you're not necessarily getting a tremendous increase of speed, but you're getting a tremendous increase in consistency and productivity and long-term use.
One of the things that just occurred to me while we were talking there is most operators will start with a pre-start check. They'll go around and check oil and water levels and all of those kind of things. we've kind of taken that away. Are you now relying upon the sort of diagnostic systems within modern excavators to generate that kind of information?
Well, so we have something called a robotic equipment operator, an REO. This is sort of the person responsible on the job site for managing the robots, and they'll still need to do checks on the machine and check levels and gauges and all the sensor information. We can rely on what the OEMs provide on their equipment, but we also like to do our own checks as well. And the REOs are kind of that responsible person. So that's kind of how we see additional skills and tasks for existing operators through becoming an REO.
Which then begs another question. Obviously, you're trying to stick, or you're recommending people stick to the guidelines laid down by the OEMs. Does this impact upon an OEM's warranty, for example? If you've not got an operator there ticking boxes and checking oil levels, and you've now got a machine doing it, does that potentially invalidate a warranty?
It can vary from OEM to OEM and what their warranties are, and even warranties you might get through dealers you're buying from. But typically, you can check the details of that and determine what the robotic system, how it affects it, since it can vary from machine to machine.
I guess the final question is, this technology really has the potential to completely alter the construction landscape. Is construction actually ready for that, do you believe?
Excellent question. I think construction is getting there. I mean, they're excited for the technology and they're ready for new ways of building. I think there's kind of a pent-up demand for better ways of construction, safer ways of construction, more efficient ways of construction. Because ultimately, I think if you work in construction, you want to be out there building things, cool things. And you can't if you're stuck with old tools. And I think that there's this acknowledgement now that if we're going to be building the 21st century, we need 21st century tools to get the job done. And that's why construction is kind of ready for that. The implementation, I think we have to approach it with safety in mind, with making sure workers are treated fairly and respectfully, and that we have a clear path of how we deploy autonomy. And that's where we get into the nitty gritty. And if we could solve those issues, I think the adoption will go quite well.
You're an absolute star. Thank you ever so much for your time.
Take care.
All the best.
Bye-bye.
Thank you for watching or listening to Tech Foresights. We hope you enjoyed the show. Please be sure to share this with a friend or a colleague, and don't forget to leave us a like, comment or a review. We really appreciate it. And please be sure to check back soon for another episode. Or better still, hit the subscribe button to be notified when each new episode drops.